Okay, 10.6 moves into radical equations. So we're taking what we've learned and solving equations now. Now, a radical equation is any equation, so it's going to have an equal sign, that also has a radical or a fraction as an exponent, because that can be turned into a radical. You solve them just like any other equation, but you have to check for extraneous solutions, which means, remember, like here, you can't have a negative inside. So you have to check to make sure things like that don't happen. So let's look at solving this one. Well, how do you undo a square root? Well, you square both sides. So we would get 2x minus 1 equals 9. Solve it like normal. And we end up with x equals 5. So then we just always want to make sure we're checking it. So if I plug that in, 2 times 5 is 10. 10 minus 1 is 9. And the square root of 9 is 3. That works. So here are the steps for solving radical equations. First step is to get the radical alone. So if there's anything on the same side of the equal sign as the radical, we want to move it. That way, all that's left is our radical. Then we want to raise both sides to the index. That's how we get rid of it. So if it's a square root, we want to square both sides. On the radical side, it's going to cancel. And then 3 squared is 9. Then we solve. And you just keep repeating 1 and 2 if there's more than one radical, which I'll show you. So now we solve like normal. So I'm going to subtract 4 from both sides. Negative x equals 5. Divide by negative 1. And I get x equals negative 5. Finally, we definitely want to check it. So I'm going to plug that in. Instead of x, I'm going to write negative 5 and then do the math. Minus the negative is plus. So we have 4 minus negative 5 is 9. Square root of 9 is 3. And 3 plus 5 is 8, which equals 8. So that works. All right, let's look at one where there's a binomial. So this one, the radical is already alone, so we don't have to do step 1. Step 2, raise both sides to the index, which when you're squaring something, it means you multiply 2 of the same thing together. So essentially, I'm rewriting this term, and then we're going to FOIL. So on the left-hand side, the radical cancels. On the right-hand side, we FOIL. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. And negative 1 times negative 1 is positive 1. Then I'm just going to combine like terms over there on the right-hand side to finish my foiling. Now we solve like normal. So we have a squared. In order to solve, we need to get the everything on the same side so we can factor. So I'm going to subtract 3x. So 3 equals 4x squared minus 7x plus 1. And I'm going to subtract 3 so that it equals 0. And 1 minus 3 is negative 2. Now I can tic-tac-toe that. We have our A, our B, and our A times C. So our factors are negative 8 and 1. Greatest common factor, multiply up, multiply across. Now we have 4x plus 1, and we have x minus 2. If we make each of those equal 0, we'd subtract 1, we get 4x equals negative 1, divide by 4. One of our x's is negative 1/4. And then this one, we would add 2. So our other x would be 2. Now we need to check them. So we're going to go back to this original equation here, and we're going to plug in the 2 instead of x. So if I did this, we would say 3 times 2 plus 3, and then 2 times 2. 3 times 2 is 6. 6 plus 3 is 9. Square root of 9 is 3. 2 times 2 is 4. 4 minus 1 is 3. 3 equals 3, so 2 is okay. Now let's do negative 1/4. 3 times negative 1/4 plus 3 equals 2 times negative 1/4 minus 1. So 3 times negative 1/4 is negative 0.75. Negative 0.75 plus 3 is 2.25. And the square root of 2.25 is 1.5. Don't need a radical there. Then on the other side, 2 times negative 1/4 is negative 1/2, so negative 0.5. Minus 1 is negative 1.5. And positive does not equal negative because of the way we graph. We can't get a negative on this one. So that doesn't actually work. This is not a true statement. So this is an extraneous solution. The only one that actually works is 2. All right, let's keep going. Here we have 2 radicals. So our first step is to get a radical alone. Well, this radical is already by itself, so we can move on. Now we're going to raise both sides to the index. So on this left-hand side, we're actually going to FOIL with a radical. So when we multiply those together, the radical cancels. Multiply by negative 1, so it's negative radical x. Same thing here, negative radical 2x. And then negative 1 times negative 1 is 1. Combine like terms, we just have 2 of those radicals. And on the right-hand side, it just cancels because there's only the 1 radical. Now, if we go back up here, solve. First, so we need to repeat 1 and 2 if there's another radical, which there is. So we first need to get this radical alone. So I'm going to subtract 2x. I get negative 2 radical 2x plus 1 equals negative x plus 1. Subtract 1 from both sides. Negative 2 radical 2x equals negative x. Divide by negative 2. So radical 2x equals 1/2 x. Now our radical's alone. We can raise it to the second power again. So it cancels the radical on this side. 1/2 times 1/2 is 1/4, and x times x is x squared. Now we can solve. So we're going to divide both sides by 2. Nope, I lied. We have an x squared, so we need to get everything on the same side. So we're going to subtract 2x. We get 0 equals 1/4 x squared minus 2x. If I want to get rid of the fraction, multiply everything by 4. 4 times 0 is 0. 4 times 1/4 is 1. So it'd just be 1x squared. And 4 times negative 2 is negative 8x. We can take out a greatest common factor here, which would leave us with x times x minus 8. We could have tic-tac-toed with a, b, a times c. And the only way to multiply something times 0 is 0. And to get negative 8 when we add, it would be negative 8. Greatest common factor, multiply across. We'd get x minus 8 and x. So same thing. This tells us one of our solutions could be 0. This tells us the other solution is 8. Shadow, chill. And then we go back to our original equation up here and plug them in. So 0. I don't know what's happening. Here we go. 0. So, super glitchy today. All right. 2 times 0 minus 1, 0 plus 1. 2 times 0 is 0. 0 minus 1 is negative 1. 0 plus 1 is 1. Square root of 1 is 1. You can't get a negative with the square root, so 0 does not actually work. It's extraneous. Let's do it again with the 8. So 2 times 8 is 16. Square root of 16 is 4. 4 minus 1 is 3. 8 plus 1 is 9. Square root of 9 is 3. That works. So 8 is our solution. So those are the different things you're going to see. Solving for a radical, foiling, and if you have multiple radicals. Now, what's different about this one? The only difference is that the index is 3. Same rules. Radical's already alone. Now we're just going to raise both sides to the 3. Still going to cancel on this side, but this time 4 to the third is 64. Now we're going to solve. So I'm going to add 7 to both sides. So 4x equals 71. Divide by 4, and I get x equals 71 over 4. Now let's check it. Oops. So 4 times 71 over 4 minus 7. Well, 4 times 71 over 4, those 4s are going to cancel. So it's really like saying 71 minus 7. 71 minus 7 is 64. The cubed root of 64 is 4, so that works. Our solution is 71 over 4. All right, let's look at this problem. Solve the equation. 600 equals 100 times the cube root of w squared to determine the weight in pounds of a bird that has wings with an area of 600. So they already gave us the equation. We're just working backwards to solve it. So the first thing we need to do is get our radical alone. So, wow. Divide both sides by 100. 600 divided by 100 is 6. Now our radicals alone. Raise both sides to the index, which is 3. 6 cubed is 216. And to undo a squared, we take the square root. And since we're looking for an actual weight, we're going to just do the square root. We're not worried about exact answers. So second squared, 216, gives us about 14.7 pounds. All right. Graphically, you can also solve things graphically. What you do is you put one side of the equation in y1. You put the other side of the equation in y2, and you figure out where they meet. So, y equals, in y1, I put x caret 2/3. And in y2, I do 3 minus x squared. Zoom 6. And now, where they meet is the solution, because that's where they have the same value. If you hit second, which is the blue button, trace, which is next to the graph button up here, you can choose number 5, which is intersect. So we're asking the calculator to tell us where those curves intersect. So it might ask you, it's going to ask you left bound. So we want to know if we're looking at this point over here, we want to pick somewhere to the left. So I'm going to move this here. You could just type a value, use the arrows, whatever. Then right bound. So we want to move those little symbols somewhere to the right of that. If you have an actual graphing calculator, you're going to have to enter one more time to guess. And then down here at the bottom, it tells you the intersection. If you're using this app, it gives us the intersection point right here. If you're using the graphing calculator, it's just going to have x equals and y equals on the bottom of the screen. So the solution is the x. We have negative 1.34. Now we would do the same thing for the other point. Second, trace 5. We want to go left of that intersection, right of that intersection. You would have to hit it again on a regular calculator to guess. And then here we have positive 1.34. So those would be our solutions, right where those two things cross on the calculator. All right, distance formula. If you have 2 points and you want to find the distance between those 2 points, you can use this formula. It is essentially Pythagorean theorem. A squared plus b squared equals c squared. A squared plus b squared equals c squared using the coordinates. Coordinates are x comma y. So your first point is x1, y1. Your second point is x2, y2. Doesn't matter which one you call 1 or 2, as long as you keep it the same. And you just plug them in. So x1 minus x2, we just plug those numbers in, squared, plus y1 minus y2 squared. Easiest way to do it is to type it right in the calculator exactly like that. So second x squared parentheses, -2 minus 1, close parentheses, squared, plus open parentheses, 3 minus -4, close parentheses, squared, gives us 7.62. We could have done it piece by piece or type it all at once. That's completely up to you. All right, the last thing we're going to do in this section is to solve for x when it has fraction exponents. If you have x to the n equals k, to get the exponent on the other side, you just flip it. So to take it off the x and put it on the k, you make it 1 over n. For example, if it's 2/3, to put it on the k, you flip it and you get 3 over 2. Once you do that, you have your x alone. So let's look at this first one. A whole number is 3 over 1. So when you flip it, it becomes 1 over 3, which is the cubed root. And the cubed root of -64 is -4. Now again, you can use that table. You could type right in here, parentheses, -64 to the 1/3, and you'd get -4 that way as well. All right, let's look at this one. 2 is like saying 2 over 1. So to get it on the other side, you have 1/2. If you wanted it as a radical, you'd have the square root of 2. So that's an exact answer. That's an exact answer. And if you want an approximate or an estimate or rounding, we would just take the square root of 12, which is about 3.46. All of those work depending on what's being asked. All right, same thing here. First, we need to get the parentheses alone. So I'm going to divide both sides by 2. So x minus 1 to the 4th equals 16. Now to get that exponent on the other side, we need to flip it. So this becomes 16 to the 1/4, which if I use my graphing calculator or my table, either way, it ends up being 2. So this is the same as saying x minus 1 equals 2. Add 1 to both sides, you get x equals 3. So that is your radical equation information. Let me know if you have any questions.